Hi, my name is Maciej Grabek and I would like to talk today about CleanCode principles, which are a set of rules to follow when you would like to create easy to read, easy to extend, and easy to maintain code in your daily work. Short bio, I'm working for Holte Software as software engineer. I'm editor-in-chief of Code Group PL. I'm Windows Phone development MVP, active speaker, author of books, articles, webcasts. And if you would like to contact me, feel free to choose one of those three available ways currently displayed on this slide. So let's see what I will talk today about. So first of all, I would like to talk about meaningful names. Then we will go to reading your own code and we will discuss this part. Then I will show you small steps principle, which is very easy to follow and it is very easy way to make your code better and better each day. Then we will focus on responsibilities, small things about magic numbers, couple words about exceptions, and I will try to show you a way how I think communication between projects should be handled. I'm not talking about just projects in the same solution, but I am thinking about communication between distributed projects. So let's go to first step, which can be even zero step, and I will try to explain why we are talking about clean code. So first of all, we have two different kinds of developers. We have smart developers and professional developers. There are, of course, many other kinds of developers, but we will focus only on those two groups. So first of all, smart developer can create very difficult code, very can deal with very difficult tasks, but this code is, tricky. Smart developer knows a lot about platform he's working with. So, for example, if we are working with iOS, we know where to go with this particular piece of code to make this application working a little bit faster. But on other hand, a professional developer can create not difficult code, but readable code and maintainable code. So the difference here is very, very large because when you are professional developer, you can create, okay, this code will be little bit longer. This code will take little more files to compile, but nowadays it's not so important that it was a couple years before, because now our power of our computers and build servers is not comparable to those which were available couple years ago. So currently we do not have to worry about this size of code. We should focus on code which is readable and easy to maintain. Then we have the second thing connected with those two is that when we are following some principles connected with clean code, our code is clear to read, clear to understand, and some example of it can be that smart developer will write R as name of variable for lowercase URL, and professional developer will write something like lowercase URL of page, which is exactly the same, but let's say after 1-2 weeks or 1-2 months, if someone will try to read this code and will find, let's say, variable called R, I think that it will be very hard for him or her to remember what was it all about. So lowercase URL of page is much more readable and clear piece of code to compare. Okay. Why we are creating bad code? First of all, because we need to do our work fast. We need to deal with all our daily tasks very, very quickly. And this is main problem in this situation. The second thing is that sometimes we are a bit tired of our project or a bit tired of our work, and then we are not focused so much. We do not have so much enthusiasm during the work, and our code is going to be worse and worse. Then we can think that, okay, I will fix it for now, make it working, and then maybe later I will clean it up. So this is the most horrible approach I can imagine, because if you will say, I'm going to fix it later, it means that you won't fix it nowhere. It's not possible to fix it in future. And why? Because we are used to create bad code. We all do the bad code. So this is another hard part of this part. Uh, okay, some other problems. Requirements are changing every day, every week, every Scrum sprint. Depends. We shouldn't think about requirements as something what is constant. Of course, there are some projects which are focused on the documentation. Nothing can be changed, but to be honest, our customer won't be satisfied after, let's say, half of year with this kind of approach. So requirements needs to be changed, needs to be alive to make this project exactly what our customer requires. And this, of course, forces on us some changes in our code. So we should think about changes, not about if there will be change, but we should think when there will be a change. Then another problem is deadline. Deadline is very hard to deal with because we need to do a lot of things in very, very quick time, very short periods of time. So this is a large problem. Then we have, of course, managers or salespeople which are trying to force on us some changes which are not discussed with the whole team, with the project manager or with the scrum master or with the client. So this is another part, and the most important and the hardest problem to deal with is we developers. The largest problem between keyboard and chair, we are we are the reason why the bad code is created. Okay, so short explanation about the rest part of presentation. This is the best code quality measurement I know. WTF per minute. And if there is good code or very good code, the amount of them will be a couple per minute. And if there is a bad code, we can hear a lot of them during 1 minute. And another part connected with this is that I introduced two colors in this presentation. So first of all, we have a green one, which is good code, and we have something between orange and red, which is bad code. So those two colors will be used during the rest of presentation to explain you what I was thinking about and which part is good, which part is not the best solution. So let's go to the first part, meaningful names. And let's think about those four examples. Here we can see different variables, x, y, temp, x, return, x, something like that. And we can think about them. Yeah, they are very good variables, but what does it mean? What exactly I would like to return from my method, my function, or something like that? maybe it will be much better if we will describe the reason, the purpose of this particular variable in our code. So let's say instead of x, I will have elapsed time in minutes or maximum possible value, something like days since last login, or my favorite way to initialize result from our method is to create variable called result at start. Then we can work with this, and at the end we have always a statement return result, which gives us more clarity during work with this code. Another thing is that in this example we have method called getDem. So first question is, what exactly is dem? What condition is for selecting the particular dem item? When we follow the code, we can see that there is an condition which is specified by first element in our um, array is equal to 4, and then this is our special item, and we would like to add this item to our result and say that this one is the dem item. So when we will look at the second part of this slide, we can see that there is much better way to write it. We can make it more readable. So first of all, instead of saying get them, I can say get flagged cells or get flag items, objects, whatever. Then I am at start, I'm creating a new instance of flagged cells list, which gives me strict reason for this variable. Then, of course, instead of this int array, I am using my class. The reason for using class is a little bit in lower part. So we can see later that we are iterating through whole, let's say, game board or something like that, the items from database, whatever. We have a list of cells, and then we are trying to find flagged item. So it's flagged cell, but the information about this condition, so the first element in my array is equal 4, means that this array is flagged. So we are hiding condition inside object to make it more easy to read for external code and our clients for our code. So in this situation, I think that this is quite clear and much easier to understand comparing with the left-hand side. Okay, let's go to another one. Here we have example with copy cars from one array to another, but the question is which one is source, which one is target? So this is first question. What is A1, AB, A2? It's not very clear in this context because I am developer, so I do not have to follow convention that a first parameter is always source, the second is always destination, because it can be easily changed. And in second example on this slide, we can easily see what is happening. So first of all, we have a source, and then we have a destination, which gives us much more clarity about what will happen in this situation. Okay, one more thing about meaningful names. Let's see those two names. They are different, but at first look, they look very similar. They are almost the same. The length of those is just one character difference. There are very different part is starting about in the middle of the word, so this gives us much more hardness in understanding this part. And in this situation we should try to prevent such names. Instead of those, we should make different parts of names. We should use them at start of our name instead of creating XYZ controller for efficient something. We should revert this name and say, for example, handling XYZ controller for efficient handling, efficient handling XYZ controller for strings or something like that. Make it more easy to understand, because at first, in first second, we won't be able to um, recognize what exactly method is called here. Then another thing, like including names of types in our methods. Let's go through this. An example method returns array of items, and the name of method is getItemsArray. Another example is with lists, but in my opinion, much easier will be to create method which returns IEnumerable, which is very flexible for the clients, and we can call this method getItems or get, if this will be, let's say, items service or items repository. Then we can much easier define this method. What is the reason? Because at start we can think about creating method which will return array of items, but then we are getting some new condition. Let's say we should use lists. So in the bad way, we need to do, first of all, we should change result type. Then we need to change name of our method, because array is no longer array, but it becomes list. So we need to change it. Too many changes caused by one very small change. In good approach, there's no difference in context of IEnumerable. Will it be array or list? It's not important. Of course, it depends on the language you are writing your code, but the general approach is to make it as flexible as possible, so it won't cause you too much problems. Another part connected with this is to prevent too much information duplicated or included many times in the same line of code. So in first example, we have specified type of variable, which is string. Then we are using str prefix in our variable. Then we have product title, which is okay. And then at the end, we have some product title in quotation. So as you can see here, we have one string, then second prefix, third is quotation, and the fourth is the general rule that title is something which is string. So we have four times in this line, we have information about type of this particular variable. The same is with the double and db as a prefix. In this context, db as a prefix is even worse than str, because db can be connected with database. So it gives us more requirement to think about what we are reading now. The better way, in my opinion, is to use, for example, string product title is equal to some product title, or if we are using, let's say, C#, then we can specify var keyword, which will remove this implicit type definition from our code. This is the hardest slide, because it's not very easy to pronounce this code. It's very important to make our code readable, so we should be able to pronounce what we can see in our code. In this situation, DTARCRD102, it's very hard to read. The same with the properties inside or private final string something which is 102. The funny thing is that at first time when you can see class which ends with the 102, you can think about, okay, this is some magic number, which I will talk about later. And this magic number is the part very com very um, very problematic for us because it can be removed from one place of code, but we won't be able to remove from different parts of code. But I will talk about it later. Let's see how it can look like. So first of all, we have class called customer, not something which can be pronounced as data record 102. Then we have, let's say, generation timestamp instead of generation month, day, hour, minute, seconds. Then we have modification timestamp exactly in the same way. And we have final string record ID 102, which is much easier to understand comparing to the PSZQIENT. So in this situation, it is much better. Okay, one word per concept means that when we are creating code, we should try to follow the same way of naming, the same types of objects, the same type of. For example, when we are getting some data from somewhere, let's say database, we should call it or get or receive or fetch or any different word you would like to see in this place, but we should use it in any other place connected with the same area. Get users, get accounts, get products, something like that. Not, let's say, get users, but fetch accounts and receive products, which will be not good approach to deal with. And the same with other types like controllers, managers, services, providers, repositories, or something like that. It is very important to follow one concept during our project. Reading your code. We were talking about one part of reading your code, but then couple more things connected with this. So first of all, 150 characters per line. This is, of course, approximate value, how much characters we should place in one line of code. Then another number which specify that our method should be about 20 lines of code. Of course, it depends, but more or less it is quite a good number. Then using blocks. I cannot imagine currently, I cannot imagine using my code without blocks. Strictly specified blocks, even if my code contains if statement with only one line below this statement. Always I'm adding the brackets because then my code is very clear. In one of my companies, in one of my projects, I was working with code where there was line with the if statement, one line with some code execution, and there was one more line, but some developer just commented out the line just below the if statement, and then condition was applied to next line. In this situation, project was stopped working properly and it was giving wrong conditions for the user interface. So this is very important to use brackets. It's not very large change. Those are just two characters at the start and at the end of our code, but I think we should use them always. Then, instead of creating many different parameters, multiple parameters in our methods, we can collapse those into one uh, class. Like in this example, we have search method, and instead of creating, let's say, 4 different parameters for this method, we can specify conditions for a conditions class, which contains all of those parameters, and then we can very easily extend this search method. Instead of adding new parameter into each usage of our method, we can just add it inside conditions and then modify our code in the proper places. There can be a question, what if I need to specify all those parameters and I will forget about some place. The very easy answer for this is that uh, instead of search method, we should validate those conditions. We should, another approach is to create a validate method inside conditions class, which will verify it for us. And then we can say, okay, those parameters are not properly initialized and we are returning some error exception. And of course, we should verify this on the unit test level, which will give us information that there is one more place or a couple more places which are initialized in wrong way. Another thing is that instead of creating many different conditions, we can collapse those conditions into something more readable. Like in this situation, if account ID is greater than 0 and the account name is not null, then we can do something. But much more understandable for us is to say, if account is valid, then do something. And we can, of course, create this method, or we can use some other way. Let's say we can create property is valid for account, or this can be extension method, whatever. And in this way, we can read our code instead of thinking about those large conditions, because currently we have only 2 conditions to be sure that account is valid. In other approach, there can be many of those. Another example is connected with large code inside our methods. So we have 2 approaches. One is bad way to create this code. So we have a lot of different operations inside our method. And better approach is to include those operations in different methods. So instead of specifying everything connected with getting items from database or some other repository, converting items, calculating items, saving those results and returning those results to our client code, we can get those different pieces of code, group them into different methods and make our code much more easier to read. So instead of, let's say we can create items variable, then using get items method, we can get them. Instead of writing whole our algorithm inside our method, we can exclude this algorithm into another separated method. Maybe in this situation, process items is not the best idea to name it, because process is like a black box. You can put there something and there are some calculation, you have no idea what is happening. So maybe it will be better like calculate discount or something like that. Then we are saving our results, returning them to our client code. So this way is much better and much easier to read and understand after some time. Don't repeat yourself is rule, which is very important when you would like to make your code easy to maintain, easy to modify. Because when you have the same piece of code used many times, there will be a time when you need to change it somehow, some way. So instead of changing in multiple places, you can do it in one place. So in this example, we are extracting validate account method, which is responsible for get this account, verify if this is valid or not. We can, of course, use it in all places where we were using a normal content of this method. And then we can imagine that there will be a piece of time, the point of time when we need to modify this account conditions, and then we have only one place to modify it, and the rest of code will be working as expected. So this is much better way to deal with this. Small steps. Small steps is a scout rule. It means that you should always leave it better than you found it. It means that when you are working with code during the daily work, there are always possibilities to get this piece of code and make it looks better, make it more readable, rework it, make some refactoring. Of course, there can be a question: what if I need to check in it those changes? Someone will ask me why you modified another part of code. Solution is very easy. You can commit your normal work, and then you are doing another commit, another check-in with those changes. They can be assigned to refactoring task or something like that, included in your project schedule. And then after some time, your code will be much better than at start. How to deal with conditions? I like to work with conditions in the way that when something is not correct, then just leave this method. So comparing to the bad example, we have first condition, then inside first condition we need to check another condition and another, of course. Between them are some pieces of logic we need to run to be sure that we have those conditions calculated. But the better approach comparing to this one is to get out from method or function as soon as possible. So let's say if condition 1 is not proper, then we should simply get out from this method. Then we are following some code, then we are checking another condition, and at the end, of course, the rest of our logic. The difference between those is, of course, not the way how they are working. The difference is only the way how it can be understood by us, how we can read this code. So in the left-hand side example, there is very hard to find the brackets when we have many different conditions one under another. It's much harder to follow which bracket is connected with which condition. In right-hand side example, it is much easier because we are checking condition, and if it's not proper, it's not valid, then we are just getting out from this method. So this approach is much easier to understand when we need to deal with some new code. And of course, according to the Scout rule, it's very easy to rework and very easy to include in your code. Responsibilities. This is very short refreshing of your knowledge about solid principles. So first principle, single responsibility principle, is the way how we should create our classes. Bad example of person class is the class where we have properties, and for example we have calculate distance method or save in db method or many different methods like this one in next couple thousand lines of code. So the problem in this is that person shouldn't be responsible for calculating something or saving it in database. For calculating distance, we should, for example, use some word class or something like that, because there can be many different ways, many different kinds of words. If we are thinking about saving person in database, it's better to create person repository with interface implementations, because there can be many different implementations for the repositories, like Azure database, like storage, some file storage, something like that. So many different places to store, and person shouldn't be responsible for doing something like that. Person should be responsible only for this defining properties, some conditions connected with the person. Then magic number. Magic numbers is a part of another presentation called anti-patterns. Number-driven development is one of terms I defined there. So feel free to watch another movie on my YouTube channel. And let's just briefly describe this. Magic number is like, for example, in this slide, we have some report, and report has a property called type. And when this type value is equal to 2, then we should do something special. But we need to guess what is 2. What will happen if I will say 3 or something different? So better approach in this situation is to use enum values. And if we are working with some database objects, we should as soon as possible convert them to something which is connected with enums, do not have those magic numbers or something like that. It is very easy to implement. We can parse string values and to get from those normal enum objects. So this is much better way, because in right-hand side example, only thing we need to do and only thing we need to understand is that if report type is cool, then do something special. In other case, just forget about this. So this way is much more easy to read than if report type is equal to 2. It's meaningless. The right hand side is meaningful. And string is another way of magic in our code. In this situation, instead of working with numbers, we are using strings, but the workaround for this is use, for example, string resources, some kind of resources, database resources, some kind of classes with constant strings included inside this class, to be sure that everything will be specified in place, easy to find place, easy to modify place, and it will be very easy to change, to modify. Let's say in this example, when someone will rename this special category to super cool category, in first approach we will have large problem. In second approach, it's very easy to deal with, because refactoring will change everything in our code. Or instead of refactoring, we can simply change value of the special category name string into cool string or something like that, and rest will be working without any more changes. Something about exceptions. So there is something called exceptions hierarchy, but before that, I will just give you an example of how we can do exceptions handling in a bad way. So first of all, we have some method which is doing something. We don't need to know what is going on there. We are catching some exception, because yes, there can be some exception inside. So instead of work in proper way, we are trying to find some magic strings inside our messages to be sure that we should do something special. Instead of this, we should first of all use inheritance. We should use different types of exceptions. We can implement them and implement different types of exceptions. Then Based on this, we have exceptions hierarchy. The most specific, the less specific at the end, the most specific at the start of our catch block, and then we are sure that the most specific one will be handled as the first one, and the interpretation, the code will try to find the most suitable exception type in given place. So if we will not meet conditions connected with our custom exceptions, then it means that something went wrong. So in catch exception block, there is real problem, and we should focus on this part really hardly. So this way is much easier to understand and much more flexible to work, instead of comparing some strings, like compare to find if there is the message is equal to range, or contains range, or starts with something, because this message can be totally changed. But our types will be much better to work with. Empty object is another pattern. There was someday a calculation how much cost us the null keyword in software development. I don't remember the proper sum, but it was very large. So instead of dealing with some null values and verifying if okay, this is null, or a value of ID in our account class is equal to 0, or less equal than 0, then it means that something is not correct, we have invalid account or something like that. Instead of this, we can compare our object returned from, let's say, repository or service with empty um, empty class, empty object defined in our class. It is very similar to string empty or GUID empty. GUID empty is not empty, it contains only zeros on all places, but it's empty, so it means it's not set, is invalid or something like that. And the idea about this empty object is exactly the same, like with those two classes, so string or GUID. Couple words about communication between projects. So first of all, internal communication. We have, let's say, repository which is responsible for getting an object. We have model which describes an object, and we have some implementation of our repositories. So we can think about those implementation as the place where we can use different objects, domain specific objects. Like in entity framework, we will have objects which are representing database. In Azure tables, we will have objects which are representing some other types. In different different storage implementations, we have totally different implementation of those internal objects. But the important thing is that we shouldn't expose them outside our implementation of repository. So repository should always stick to something which is general for us, like person in model, then iPerson repository should always return person from model, not like in this example DB person or something like that. It means that we need to create, of course, some mapper or something like that, but it gives us 100% sure that changing repository implementation to some other implementation will not issue our code in rest parts of our code. Something about external communication. Let's think about web API and the client, and how we should communicate with this client. First of all, we should introduce to our code something called a DTO. It means data transfer objects. Data transfer object will be in most cases something which is one by one exactly the same like a model in our code. But the reason for that is we need to be sure that this DTO object won't be changed in any condition. It is constant, it is contract with our clients, so it cannot be changed without communicating with our clients. It should be resistant to any internal changes in our code and, of course, in our model. So we can think about this DTO and normal model. For example, we want to change the property name in model person, but we shouldn't change this in person DTO, which is exposed to the client, because we can, for example, communicate with JSON protocol, with JSON format, and JSON is string based, so changing the property name will totally change the output content of our web API, which will invalidate proper way of working for the client. So in this situation, we should prevent this kind of approaches. This is more or less the end of this presentation. If you have any questions, feel free to comment this video on YouTube. I will try to answer those questions. And a small bonus from me for the end of this presentation. It is strongly connected with the code and how code reviews can be done in a little bit better and more funny way. Thank you for watching. Thank you for listening. Feel free to subscribe to my channel on YouTube and see you during next video. Thanks. Bye.